As Hong Kong continues to grow, so do sewage loads. Sewage is everything that goes into sewers, including used water from toilets, kitchen sinks, laundries, and industrial processes. It needs to be properly treated before being discharged to the sea. Harbour Area Treatment Scheme HAT Stage 2A improved the water quality of the Victoria Harbour by enhancing our sewage systems to increase the treatment capacity. As the project consultant, we are responsible for the design and supervision of upgrading Hong Kong's largest wastewater treatment facilities at the Stonecutters Island and 8 preliminary treatment works on the Hong Kong Island. These preliminary treatment works collect wastewater from the north and southwest shore of Hong Kong Island and filter out the debris. The water is then transported via a 21 km subsea deep tunnel system to the Stonecutters Island sewage treatment works. The sewage catchment area of HAT Stage 1 is 69 square kilometres and 26 square kilometres for Stage 2, comprising the northern and southwest shore of Hong Kong Island.
We have projected the flow based on the population and employment data for the next 2 decades. We have built our GIS model and calibrated with the historic flow and records in order to project the flow from the initial commissioning years up to the year 2031.
We built the hydraulic model to assess the velocity and head losses through the tunnel, water levels at various drop shafts, and depth of the main pumping station under average and peak flow conditions.
There were 3 main purposes to build the hydraulic model. One is to calibrate the hydraulic performance for the stage 1 and determine the roughness. And second is to design the hydraulic design for the stage 2, find out the tunnel sizes and the invert level of the drop shaft. And the third most important is optimize the overall hydraulic performance for the HAT system by including stage 1 and stage 2.
To accommodate the additional sewage flow, the upgrading works include a new main pumping station, an interconnection tunnel, additional sedimentation tanks, new sludge dewatering facilities, and a new effluent tunnel.
The pumping station was on the critical path. So we took the decision, quite a risky decision, that we would de-link the construction of the underground works from the M&E works. So we did a lot of upfront design, much more detailed design than we would normally do, to set the parameters for the diaphragm wall and the excavation works. And we did that work as an advance contract.
As one of the largest in Asia, the main pumping station has a diameter of 55 metres and a depth of 40 metres. Comprising 8 pumps, each capable of processing a volume of sewage equal to 1 standard swimming pool every 10 minutes. It lifts sewage collected from the north and south of Hong Kong Island, from the deep tunnels that convey the wastewater across the harbour. Construction within a live operating treatment works is a constant challenge. All the works and logistics have to be coordinated with the end users at the Stonecutters to ensure safety and avoid interruption of the plant's operation. Due to the complicated ground conditions, an interconnection tunnel with a diameter of 3.9 metres has been constructed using a tunnel boring machine.
In our short drive, 250 metres, we come across marine deposits, alluvium, completely decomposed granite, all of which will carry water, and that's dictated the use of an earth pressure balance machine. We've supplemented that with specialist ground freezing to break out of the shaft and break into the reception shaft.
Sewage will be pumped into sedimentation tanks for primary treatment to remove the majority of the suspended solid particulates. New tanks have been built to join the existing ones. A decentralized and compact deodorization system has been installed to treat the odorous gases produced from the sewage treatment works before discharged into the atmosphere. All the primary sedimentation tanks have been fully covered. The foul air is extracted and conveyed through the odorous duct to the biotricking filters for treatment.
Odorous gases from the wet well of the main pumping station has been extracted and conveyed to the biotricking filter, followed by the activated carbon. The multi-stage chemical scrubber, followed by the activated carbon, has been used for the sludge house.
Sludge left from the sedimentation process will be sent to holding tanks, where it is eventually dewatered to become sludge cake. They will then be transported using sealed containers for incineration to generate electricity at the sludge treatment facility at Tuen Mun, also an Arup project. An integrated control system combining HAT Stage 1 and Stage 2A operation has been designed to allow full automatic control of 10,000 field equipment, such as main pumps, sludge centrifuges, and deodorization units in 30 process areas in the Stonecutters Island sewage treatment works and primary treatment works.
The existing system was designed 20 years before and almost obsolete. We have to conduct a detailed site survey to evaluate the condition and performance of the existing system, and to design the approach of integrating individual systems as one system. Finally, we have designed the system which can perform the best in the factors of risk to the plant operation, technical feasibility, procurement strategy, time, and cost.
The original scheme adopted a conventional arrangement consisting of a short effluent tunnel, a large above-ground disinfection tank, and connection culverts.
When we take up the HAT Stage 2A project, we have come up with an innovative solution of combining both the effluent tunnel and the conveyance system, such that the above-ground chlorine contact tanks can be totally eliminated.
The optimized scheme could provide up to 40% of the life cycle cost savings, and ensure adequate contact time for disinfection inside the enlarged and lengthened effluent tunnel. The land required for building the contact tank can also be saved for other beneficial uses. After completion of HAT Stage 2A, the capacity of the Stonecutters Island sewage treatment works will increase from the current 1.7 million cubic meters per day to 2.45 million cubic meters per day in average dry weather conditions, and 4.1 million cubic meters per day in wet weather conditions. Ultimately, it will serve 5.7 million people on both sides of the Victoria Harbour. Due to cleaner water following the commissioning of HAT Stage 1, Hong Kong's annual cross-harbour swimming race resumed in 2011 after a 33-year suspension. Completion of Stage 2A will further improve the water quality, and this iconic cross-harbour race will be able to return to Tsim Sha Tsui in the near future.